Hey there, young scientists. Ever wondered why an apple falls to the ground or why the moon doesn't crash into Earth? Yep, that's gravity at play, the most mysterious yet universal force holding the cosmos together. Now imagine you drop your pen. It falls. The same force pulls the planets around the sun. They crazy, right? Every object in the universe, from your water bottle to Jupiter, pulls every other object toward itself. This invisible attraction acts along the line joining their centers, equal in strength, opposite in direction. It's a perfect tug-of-war that keeps the universe in balance. So, next time you drop something, just smile and say, "Thanks, Newton." Because that's gravitation showing off. Alright, let's put some math muscles to this mystery. Newton gave us a simple yet powerful equation for this universal attraction. He said, the gravitational force between two objects depends directly on the product of their masses and inversely on the square of the distance between them. In his words, F equals G multiplied by open bracket m1 times m2 close bracket divided by r squared. Here, F is the force in newtons, G is the universal gravitational constant, 6.67 times 10 raised to the power of minus 11, and r is the distance between their centers in meters. What's magical is that this law applies everywhere, whether it's the moon orbiting Earth or you holding your phone. And remember, as distance doubles, the force becomes 1/4, so gravity weakens super fast with distance. Now, let's zoom into Earth, our home planet, the giant magnet of matter. The Earth pulls every object toward its center, and this pull produces an acceleration called g, the acceleration due to gravity. Weight, my friends, is nothing but that gravitational pull. We say weight equals mass multiplied by g. So if you have a mass of 50 kilograms, your weight on Earth is 50 times 9.8, which is 490 newtons. And yes, G equals capital G multiplied by open bracket capital M divided by r squared close bracket. That's how we find G, using Earth's mass and radius. Now, fun fact, G slightly changes with altitude, depth, and even latitude. So technically, you weigh a tiny bit less at the equator than at the poles. Don't worry though, not enough to skip your workout. Okay, picture this, you drop a coin from your hand. It accelerates as it falls, not because it wants to, but because Earth's gravity tells it to. This motion is called free fall. During free fall, the only force acting is gravity. The acceleration remains constant, about 9.8 meters per second squared, straight down. The same old equations of motion work here too, just replace A with J. A resistance can mess with it a bit, but in a vacuum, everything, a feather or a hammer, falls with the same acceleration. Apollo astronauts even tested this on the moon, no air, same fall rate. So, let's wrap it up, space explorers. We learned that every mass in the universe attracts every other mass. That's Newton's law of universal gravitation, F equals G times m1 m2 divided by r squared. On Earth, this gives rise to G is equal to 9.8 meters per second squared, which defines our weight, W equals m times G. We also saw how objects fall freely under gravity, obeying motion equations with G instead of A. In short, gravitation is the invisible glue of the universe. It keeps planets in orbit, tides in rhythm, and you firmly planted on the ground. So next time you trip over your bag, remember, it's not clumsiness, it's physics in action. See you in the next session with another amazing concept of physics.